Okay, so we've had a look at examples where we've had to find the equation of your cubic graph, and we've done it either if we were given 3 x-intercepts or if we were given 2 x-intercepts where the one was bouncing off the x-axis. What happens if they don't give you any x-intercepts? If that's the case, then the next thing you would have to ask yourself is that, okay, so no x-intercepts, but are there turning points? Because if there's turning points, then we can approach it from a whole different angle, all right? Fundamentally, this is what we need to remember. If you've got a cubic graph, as I've given you a very basic one over here, the turning points, which remember we could call stationary points, are at these two spots over here. Now, if I were to draw a tangent to the line at the two turning points, do we agree that the gradient of those two tangents is absolutely flat? There's no slope, okay? So we know that the gradient of your tangent, which in calculus we should all remember equals the derivative. So the gradient of your tangent is flat. It's equal to 0, okay? And that's the fundamental concept you need to use here to work this out, to work out the equation of this graph, all right? So we're being asked to find the equation of, in fact, we just need to fill this in. It's an ax cubed and it's an x squared over there, okay? Given to us is the point 2 and 9, which is a turning point on the graph of f of x. Determine the value of your a and your b if that has been given to you. Do you notice that they've given you a little bit more information in this example that they have done in previous ones? And that's quite typical. So you'll find that, yeah, if you've only got turning points, you may find that they've actually given you part of the equation already there, okay? All right, how are we going to do this? Because they are telling you that 2 and 9 is a turning point. Turning point means derivative equals 0. And that is exactly what we are going to do. We are going to calculate the derivative of your function, all right, which is actually going to land up being 3ax squared plus 10x plus 4. All right, that's the derivative of your function. And what did this story say over here? At the turning point, the derivative is equal to 0. Okay, so we're going to make the derivative equal to 0. All right, we have a small issue, however, that I've got two different variables I'm working with over here. I've got an a and I've got an x, and that's not ideal, okay? But what we do know is that the x coordinate at the turning point was actually 2, all right? So you can use that. So we're going to substitute x with 2. So I've got a 2 squared plus 10 times by 2 minus 4, all right? And that's going to land up giving me an a value, which is negative 2, okay? Now that I've got the a value, we can then say, right, let's substitute that a value back in there, all right? So we're going to say we've got, let's change our pen color, let's make it blue. So we're going to say, therefore, we've got y is equal to, instead of a, I've got negative 2x cubed. All right, then they gave me the 5x squared part. They gave me the 4x part, and then we've still got this b to solve for, okay? Now this is what we do. The points of 2 and 9, which they told me in the original question was the turning point. It's all very well that it's a turning point, but if you think about it, it's also just another point on the graph. You know, it's a point that's sitting on the graph. So we've used the 2 and the 9 in the context of it being a turning point by making the derivative equal to 0. Now I'm going to use the point 2 and 9 in the context of it being just a point on the graph. And if it's just a point on the graph, I'm quite simply going to just substitute it into the equation. So instead of y, sorry, we've got 9. And instead of x, we've got 2's. And basically, obviously, as you can see, that then is going to leave us with b to solve for, okay? Which again, I'm not going to subject you to all that working out. We're going to just tell you that b is equal to negative 3. But please do it for yourself, okay? I do want you to actually make sure you can get there. But that gives us a final equation of y, which is equal to negative 2x cubed plus 5x squared plus 4x, and then minus 3. Okay, go over that video again. It's an important one to get your head around, that you can use a point as a turning point, and that involves using derivative equals naught. And then you can use the same point as just a point on the actual function, and you just sub it into the actual function. So if you understand that, it's really great because it often comes up in this kind of question. So well done. We will see you in the next video.